Hello, grade 11 students. I'm here with you to discuss the solution of this exercise. It's very important. I want you to follow up. Draw the figure always and write the given. The given is that the initial speed was 0, no other given in this question. I want to add something here. They told you that the mass covered certain distance m. Let's say it moved down, and it became here. So it covered a distance x. Okay, this was the exercise. In part 1, they want you to find or use the kinetic energy theorem to find v squared in terms of these variables given in the question. Before I start just copying the equation or the formula and apply what I know, I have to do something first. I have to list the forces acting on the system. Okay, this is the first analysis I have to do. There is weight on this mass. Here I have to, the weight on this mass. Here I have to specify the external forces and not the internal forces. I don't need the tension because I'm discussing the whole system. I want only the external system and the external forces acting on all of them. So I have the weight of this and the weight on this. So this is the weight of the smaller mass and the normal reaction. The normal reaction, the work of the normal reaction, always it's 0. So this is the work, not the weight. And I want to ask myself, what is the work done by this weight? The work done by this weight is 0. Why, guys? Because simply the weight here is perpendicular to the path. So the one doing the work is this weight. Okay? So this weight is doing a work because it's released downwards and then it moved all the system. Let's apply now KET, which is kinetic energy theorem, which says that delta KE is equal to the sigma of the work of the external forces. You see, only the external, not the internal. Here, kinetic energy final minus kinetic energy initial, it's equal to the work of the weight of the bigger mass and the work of the weight of the smaller mass and the work of the of the normal. You see, I can't just start applying here. I have to do this analysis before. So this is 0. This is 0. And this is 0. Why? Because the speed is 0 at the beginning. Kinetic energy final, which mass is possessing kinetic energy? Both, because finally both moved. So here I'm talking about the kinetic energy of the bigger mass, which is half mv squared. I'm talking about the final, plus half mv final squared of the smaller mass, equal to the work of the weight of the smaller mass, and the work of the weight is directly, simple rule, mg h initial minus h final. Okay, guys, direct application. Here you have to note that these speeds are equal. Why? Because the string is inextensible. So if this moves with mass or this moves with speed v, then this will move with a speed v again, okay? The same speed because the string is inextensible. So it will be half mv squared. Both are moving with speed v as noted in the question, equal to mg. What is the difference in the height covered? So the distance covered is x. I take just common, it's half, and common thing v squared. So the common factors are v and half and half. The rest is between parentheses, so I reach the answer. I can express v squared in terms of mg. I multiply 2 crisscross over m plus m. I hope that you're following up, copying the answer, practicing, because only watching is not important. It's important, but it's not helpful as much as writing with me. Okay, guys, number 2. Deduce. I have to use this. Okay, deduce the acceleration. So what is the relation between the acceleration and what we have got? You have to relate, or you have to know, I think you know that a is the derivative of v with respect to time, right? This is taken in kinematics. We studied that in the class, we put it on the wall, just the derivative A is dv over dt, and we denote the derivative of v with respect to time by v prime. I want to use here a mathematical relation which says, please aside, I need this math that u, the derivative of u squared is 2u prime u. Please, I will use it, it's very important. U squared is, the derivative of it is 2u prime u. So, I'm gonna use this. I'll derive it with respect to time because I want to deduce. So I will derive it. This is the relation between these two, the derivative. The relation is, I will copy it, I got it from the previous part, 2mgx over m plus m. So it is, I just derive all of this with respect to time, prime. So it's v squared prime equal to 2mgx over m plus m prime. Okay, guys? So I wanted to have a look. I wanted to copy them. Okay, concentrate, it's easy. V squared prime, so it's u squared in math. How to derive it? It's 2v prime v, okay? Math, equal. Here, before I decide to derive, I want to ask myself, which term is the variable with respect to time? Can I derive the mass with respect to time or the g? The g is a constant number, m plus m. So I can derive them, but the derivative of them is 0. So I will put the constant aside, as you do in math and the derivative. In the derivative of, let's say, 2x, it's 2, right? 2x is 2. You don't derive 2. You derived it, but it's 0, plus the derivative of x prime. Then m plus m, x prime. Right? Okay, guys? So here, what is v prime? What is v prime? Blah, 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 blah. What is v prime? V prime is a. So instead of v prime, it's a. It's easy. Don't worry. Equal to m g m plus m. What is x prime? What is x prime? What is the derivative of position with respect to time? It's a grade 10 question. Everybody knows that the variation of position with respect to time is v. So here I used two relations. V prime is a and x prime is v. V and v will cancel up. Easy. 2 and 2 will cancel up. Then a is mg over m.